Hi everybody, and welcome to Advanced Memory Forensics of Windows Operation System, Threat Hunting and Initial Malware Analysis. This is a two-part series where in the first part I will show you the memory forensics and threat hunting, and in the second part I will show you the initial malware analysis and reverse engineering of the results from the first part. So there are some information related to sample which is used in this video and in all this exercise. You can see the MD5 hash is here. The malware family of the sample is Loki ransomware, so be careful, it's a real world sample. So run it only in your VM. The links to download this sample are available here. You can download it from AnyRun, which is basically dynamic sandbox. If you download it from AnyRun, the password is infected. And if you download it from my GitHub page, the password is malware. The links to videos are here. You can see the link to first part. The second part is in the process. You can see all information related to first part here, and the second part is here. As I already tell you, it's in process. There are also references on my GitHub page to all tools which I will be using or I will be mentioning. So here are the links where you can get some information or download these tools. So let's jump to the first part where we will be talking about and doing memory forensics and threat hunting. You can also download the memory dump I will be doing and dumping here from my GitHub page. So if you want to skip the steps like memory acquisition and other stuff, so you can download the memory dump covered in this video. Content of the first part. Tools, usual tools I quite recommend for memory forensics, initial malware analysis, threat hunting, and others. Usual steps, something like GOT. Basically, you can see it here. Here are steps which are covered in this video. So if you want to repeat it, it should be quite easy if you follow these tips, to follow this GOT. Other thing is threat hunting using volatility-free and YARA rules, carving pcap from memory dump. I'll be using bulk extractor, which is basically a very good carving tool, which works on a binary file, and it's able to carve a very wide range of artifacts. I will be using it for dumping pcaps from memdump. Investigating network artifacts from carved pcap, we'll be using Varshark and PowerShell for filtering and sorting these related artifacts. And in the last section of this part, we will be doing portable executable dumping from a memory dump and its repairing, because if you dump something from the memory, it has to be repaired, like import address table should be repaired, and it should be unmapped from virtual address space to raw. I will show you later. So covered in video in this first part, we'll be using magnet encrypted disk detector known as EDD. It's a tool from Magnet company. It's a free tool and it's a very useful tool because it's able to detect all kind of encryption, disk encryption or volume encryption. And if we detect some running encryption on our disk or volume, the next steps after the memory acquisition should be different. Basically, if you detect running encryption, you should consider performing leaf disk imaging, because when you come to leaf machine and it's running and encryption is running too, you shouldn't turn it off after memory acquisition. I highly recommend to try to perform disk imaging on this leaf machine to some external drive, and after that you can turn it off. It's right that the encryption keys, there is high chance that the encryption keys are in memory dump, but it's harder to recover these encryption keys and to use it to decrypt the image. So magnet encrypted disk detector, very useful tool. Magnet RAM capture for memory acquisition, highly recommended because it's one standalone tool, very small and very fast. You will see it later. Volatility free for memory forensics and YARA rules for threat hunting. I will be using the memdumppath YARA rules, which are downloadable here, and you can download another YARA rules from GitHub repository here. I'll be using also the YARA rules merger, which is basically my very simple PowerShell script for merging a big amount of YARA rules to one big YARA rule. You can see it here, very simple. Basically, you give this script only the path, which contains like, for example, hundreds of YARA rules, and it will merge it to one big YARA rule. And after that, you can use this merged YARA rule with volatility. We will be using YARA rule for interesting strings template. I create the template here, you can see it here, but you should replace these strings with your suspicious or interesting strings. Bulk extractor, as I already tell you, for carving pcap from memory, Varshark network artifacts from carved pcap, and PE3vol, which is basically P3 volatility free plugin. P3 is tool which is written in Python 3. It's something like a portable executable viewer, but it has some new plugins. Basically, one of these new plugins is that P3 can work with volatility free, and this plugin is able to dump process module from a memory dump and automatically repair import address table and unmap it from a virtual address to raw. Very nice tool and reliable. Another tool for basically the same purpose could be is P unmapper. This tool is made by Hasherazade, and basically this tool is able to process memory dump and for example memory dump of some module, and it is able to unmap this module from virtual space to raw and automatically repair the import address table and other stuffs. Very useful tool. We will be probably the first one which are using this tool, who are using these tools, use this PE unmapper on memory dump with cooperation with volatility. Tools. As I already tell you, use tools and usual tools when you are working with or working on memory forensics and other stuffs related to it. So encryption detection, magnet encrypted disk detector, as I already tell you. Magnet acquisition tool, I'll be using in this video magnet RAM capture, and I highly recommend this tool. Very reliable alternative is Belkasoft lib RAM capture. It's the same as magnet RAM capture. It's able to dump memory from all kinds of Windows operation system, no matter if 32-bit or 64-bit architecture. WinPM is another good alternative, and the big advantage of this tool, WinPM, is that it's open source, a very small tool and very reliable. And other tool which is able to do memory acquisition, and you probably know this tool, is FTK Imager, but I don't recommend it because it's a very large tool. There are many features, not only the memory acquisition, like for example disk viewer, file system viewer, and other stuffs. And so we will be using only this free. I highly recommend this free because they are very small. Their purpose is to do only the memory acquisition, and also FTK Imager. There is no official version in there is no portable version released. So the latest FTK Imager is only installation, and I don't recommend it for memory acquisition. Memory analysis tools, volatility 2 and volatility 3. Volatility 2 has some advantages. Basically, it has like 3 times more plugins than volatility 3. I found it quite more reliable because it was developed for very big times. Yeah, so There are some plugins which basically works better and are more reliable than volatility free. But the advantage of volatility free, it's still in developing, and it's written in Python 3, and it's much faster, much faster. And you don't have to specify, for example, profile of the memory dump, so you don't have to care about specifying memory address space, yeah, and what kind of operation system is the memory dump from. And another alternative is to use Volatility Workbench, which is basically a tool made by OS Forensics, and it's a graphical user interface for volatility free. So I quite recommend this tool for the beginners. Recall, another tool for memory forensics. It's a tool made by Google. Quite a good tool, something like volatility, but yeah, there is advantage. You can use recall on live machine, on live operation system, not only on offline memory dump. But the disadvantage is that this project is for some time archived and not in current development. So still recommended volatility. Another tool is Redline. Redline is tool made by FireEye company, and it has nice graphical user interface, but I found it quite not much reliable when you are working with Windows 10 memory dumps, but it depends on you. Bulk Extractor, I already mentioned this tool. Hex editor, basically we need hex editor for everything, but in this case I quite recommend 010 editor, file insight plus plugins, or HXD. 010 editor is free only for 30 days, so after 30 days you should reinstall this the 010 editor, or you should buy it. And YARA rules for threat hunting. Dump.py and repairing dump.py repairing tools. Basically, we'll be using three alternatives. The PE3 tools, the PE3 wall, which is basically, as I already said, PE3 volatility plugin. Another way is to use volatility 2 or volatility 3. It has built-in feature to dump module from process memory and automatically repair it. And PE unmapper, I already mentioned the purpose of this tool. Malware analysis tools, basically, when you dump some portable executable from memory and already repair it, you can use all kinds of usual malware analysis tools. I quite suggest again YARA and YARA rules. Kappa is very good and useful tool from FireEye company. It's able to tell you about capabilities of the sample. Very good tool. IDA3 or Pro, basically for reverse engineering, and Ghidra, open source tool for reverse engineering, and Cutter for reverse engineering and debugging. X64DBG, one of the best debugger, open sourced. PBER, PStudio, CFFX Explorer, and Resource Hacker for portable executable viewing and doing some initial malware analysis. Strings, don't underestimate the power of the strings, because strings can tell you about indicators of compromise, about some potential capability of the sample, and for example network relating stuffs and other things. So I'm mentioning for tools, I will be using Flare strings and String Shifter, but these are very useful tools. Floss is tools which is able to print you not only Unicode and ASCII string, but it's also able to print you stack strings from the sample. You can process, for example, portable executable format and shellcodes. But it has another very good feature, that it has built-in emulation, that for example, if your sample is implementing some function which serves for string obfuscation, it can emulate this function. It can find this function, emulate them, and print you the deobfuscated format of the strings. So very useful tool, full-featured. Strings2 is something like floss, but it has no built-in emulator. So basically it can print you stack strings, Unicode strings, and ASCII strings. Flash strings is an alternative for sysinternals to strings. It's able to print you ASCII and Unicode strings. StringZifter is another tool from YARA company, very useful tool because it has built-in artificial intelligence to automatically process results from, for example, flash strings, and it will sort them and rank them from the most interesting and potential most malicious to the less malicious and less interesting, for example, to some messy strings. So very useful tool. And here is the guide. So we can jump to our VM and start to do memory acquisition. You can check that here is my VM of Windows 7. It's already infected, but you can see also that my lab contains another virtual machine, and it's Remnux. Basically, I'm using Remnux to simulate network services because, as I already tell you, this is a real world sample, and I don't want to let it communicate to internet. So I want to control the lab, and I'm redirecting all network from this VM to Remnux. And here I'm emulating the network services with the tool called inetsim. You can see it here, inetsim. So let's jump here, and as I already tell you, first of all, run edd. And you can see that it's checking running processes and disk and volumes, and it's basically able to detect TrueCrypt, PGP, BitLocker, VeraCrypt, and other stuffs, but you can see that nothing of them were found. So this disk or this volume should not be encrypted, so we can easily continue. You can see here is also fakenet. As I already tell you, we are using inetsim, but you can use also the fakenet for network services simulation in this VM. But fakenet is quite chatty, and it will cause some messy stuffs in our memory dump. So I decided to use the inetsim and Remnux. Now it's time to do the memory acquisition. It's really simple. Before that, we can check one thing. As I already tell you, magnetogram capture is one simple standalone application. How does it possible that this standalone application is able to dump memory from 32-bit and 64-bit operation systems? It's basically, if you open it in with CFF Explorer, you can see that it's portable, executable 32-bit application. 32-bit, it means that it can run on a 64-bit operation system and 32-bit operation system. But what is important is if you jump to resource editor and check the custom, you can see here are 4 executables. These are drivers. These are drivers for 64-bit operation system and 32-bit operation system. There is driver for Windows 10 and for operation system Windows operation system before Windows 10, and the same for 32-bit. So this is the reason why this standalone tool is able to dump memory from all kinds of Windows operation system. So let's jump back, and you have to specify the path where the RAM will be saved. So to desktop, and name it, for example, memdump, and save it and start. You can choose if you want to split it, but we don't want to split it. Start. And it should be quite fast because I set the VM to have only 1 GB of memory. After you perform the dump, we can close all virtual machines and jump to work on our memory dump. And it's done. So now we can close it. Here is the memory dump, and we can jump. Basically, this memory dump you can download from my GitHub page, so you can skip all these steps. and we can shut down the virtual machines and jump to work on our memory dump. So here is the dump memory from our infected VM, and first of all what we will be doing is to run bulk extractor and the graphical user interface BE viewer. Go to tools, run bulk extractor, and we will be processing the memory dump image. So specify the image file. Let's find it. It should be somewhere here in dumped and memdump. Open, and output directory should be the same. This is the directory where the results from the bulk extractor will be saved, and also the carve pcap. So now you can uncheck all of these options because we are not interested in these artifacts. They are very useful too, but we want to only carve out the pcap. So let's only use the net scanner, because this scanner is able to carve out the pcaps from the memory dump. Submit, run, and you can see that it's running pretty fast because it's multi-threaded, and it shouldn't take a long time. After that, you will see the pcaps in dump directory, and we have to open the pcap in Varshark and try to find there some interesting strings or suspicious strings, which we can use in YARA Rule. And the YARA Rule we will be using to trying to match these suspicious strings in some specified process. So you can see that it should be done already. Yep, it's done. So you can go here and mark it, and file, and close all reports. Now we don't need these results. We are only interested in the pcap. You can see it here. So let's open it in a Varshark and try to find something interesting here. Something quite suspicious. So first of all, we can check, for example, HTTP. We can see HTTP, but you can see only the responses. Basically, these are responses and not the requests. And as the responses are from our emulated services, these responses are not relevant for us. So let's try to find something more. You can see some DNS name here, and this looks quite suspicious. So if you don't have the column name here like this, you can create this column like this filter DNS, and basically you want the DNS names like this in this column. So choose one of the DNS, for example this one, DNS name, queries, and here click here, and here is the name. Just drag it and drop it here, and you can see that here are the DNS name which we're requesting and responding. So now, can you spot something suspicious or interesting? Microsoft Node. This node, this is related to process hacker. I ran, but these are very suspicious. It looks like some kind of domain name generation algorithm, which basically generates some random domain names and try to resolve them. So you can use these suspicious domain names in our YARA rule. So if you want to save all the names in some output and only filter this randomly generated, so Control A, mark all of these, click File and Save or Edit, Copy, and as CSV. Yes. Now create new file, and let's name it dns.csv. Yes. Open this file in some editor, or for example, hex editor, and just copy what we just paste here what we copied from the Varshark. You can see this is the CSV. Nice, you can see headers here, and you can see that all values are delimited with comma. So save it and close it. Now we want to sort it and filter the DNS names, so we will be using PowerShell for this. And basically you can do something like this. Import CSV path DNS CSV, and delimiter will be comma, and save it to some variable, for example DNS. Okay, you can print the DNS object, DNS, and for example format table all properties, and you can see it here. But we want only the names, DNS names, and we want to filter it, sort it unique only values. Okay, so we can do it like DNS.name. Yes, but we want only unique values. So sort object unique, and you have here only the unique values. Copy them and create new file. You can name it, for example, suspicious strings. Let's open this file and copy the results from the PowerShell like this. And now you can delete the values which are not interesting for us. Microsoft, Process Hacker, OCSP, like this, AJ32, and leave only the DNS names which look like random generated. And you can see that we have 8 suspicious strings here. So save it and leave it for the next time we will be creating the YARA rule. We can delete DNS and we don't use anymore the pcat. Okay, let's close the Varshark and try again. Okay, maybe we can create our YARA rule of containing suspicious string. Now you can download the template here, and if you download this template, just replace these strings with your suspicious string. So let's jump back. My template is already here. YARA rules, suspicious strings, and open it in. I highly recommend the Visual Studio Code because it has quite a nice extension for YARA rules. You can find the extension here. If you write here the YARA, you can see that I already installed this extension. You will get syntax highlighting and other stuffs. Very, very nice. So what you can do, you can now open the suspicious strings we have here and copy them and paste them to the template. You can see that here are 8 values of suspicious strings, and I have here only specified 7. So just copy this and create another one entry. And specify string 8. Now, if you want to copy them all and paste them all, just mark them from down to up, like this. Copy them here select only one, right click, mouse right click, and change all occurrences. Like here, like this and this. And nice, you just copied all the suspicious strings in new YARA rule. This is a very simple YARA rule, only for detection of suspicious strings. We'll be using this YARA rule for detecting the suspicious string in some processes. Save it and leave it. We don't need the suspicious strings anymore, so you can delete them. And let's jump to volatility 3 and start our memory forensics. So basically we will run PowerShell. And first of all, what I want to do is to create a variable which will hold the path to our memory dump, because I don't want to specify the path to memory dump every time in volatility. So I just want to use some variable. You can see the full path here. Just mark it, copy it, and jump back to PowerShell. We don't need this PowerShell anymore. Jump back here. You are in folder of volatility 3 and create some variable like memdumppath, EQ, and the path to memory dump. Okay, so now we will be I will print a help for volatility, because I want to show you something. Help, and we will be using only arguments as f for specifying the path to our memory dump, and also the r, because it's a render option and we can modify the output format. Yeah, it will be very useful, for example, to change to print results in pretty format or in CSV, so we can more process it in PowerShell. I will show you later. And you can see there are many plugins, many help. How you can remember all these plugins? If you want to print only the Windows plugins, you can do it very easily like this. Pipe it, select string, and only Windows dot and simple match to avoid a regular expression. And you can see here only the Windows plugins. First of all, we will be using the Windows info to get information about operation system from where we dump the memory. So we can do it like volatility, f our variable memdumppath, and here is the plugin Windows info. Let's run it. It should be fast. And you can see it was dumped from Windows 7 Service Pack 1, and it was 64-bit operation system. Noted, it was 64-bit operation system. This will be very, very important information. So you can clear it and again print all Windows plugins. And basically one of the most used plugin is to list the processes. So we will be using Windows PS list. If we can spot some suspicious or interesting process. And you can see that the output format, it's quite messy. Yeah, you can see here it's strange. So if you want to do a pretty print, you can specify the render option here, R and pretty. This pretty option will work when you have quite a small output from the plugin. If the output will be big, for example, some large lines, the output will be very messy too if you don't have set the width size appropriately. So I will suggest the pretty option only on some plugins which will basically output very small results. But here it works fine. Can you spot something interesting here? You can see MRC, which is basically magnet RAM capture. It was our tool for a memory acquisition, so this is not interesting. If we can see something interesting, maybe you can see WOF64. WOF64 means is this is this process 32-bit process or 64-bit? You can see that these are 64-bit processes. You can see here 32-bit process, RMCVC, RMCVC, but what you can see here, that here is running some SVC host, and it's 32-bit process, but other SVC hosts are 64-bit. Basically, SVC host running on 64-bit operation system should be 64-bit process. And you can see here there is one which is 32-bit process. So this is very interesting process and probably suspicious one. So let's note this bit 2852. 2852. Maybe this will be the one we will be interested in. So now I quite like another plugin which is called PS3. This plugin is able to print you a process tree where you can see the relation between parent process and child process. Very nice plugin. And you can do it. You don't need this render option here, and just use the plugin PS3. Yep. Can you spot here something interesting? Explorer, under Explorer, you can see the magnet RAM capture and VBox tray, which is basically VirtualBox process related. So you cannot see here anything interesting, but what you can see that our suspicious or interesting process which had process ID, I can't remember, so let's scroll. You can see here 2852, and 2852 is running under services. So maybe someone tried to hide it below the services, because if you see SVC host as a child process of services, so basically services is the parent process, there is nothing suspicious about that. There are plenty of them. But this is a very interesting one because it's 32-bit and other are 64-bit. But it's still not the evidence that this should be the main point of interest. But we can use another plugin which is called Commandline. So let's print all plugins. And you can see the Commandline plugin somewhere here. This plugin is able to print you command line and arguments with which your process was ran. You can also see the main module system path, so it's quite nice and useful. So you can use it like this. Yep. But what you can see, another messy output. So if you try to use the pretty option, rendering option here, let's check what we got. And it's not better. It's not better. So I will show you how can you see it in a better format. So let's clean it and choose the render option to CSV, because we are working with PowerShell, so CSV, and we can convert the CSV output. So like this, and convert from CSV, delimiter will be comma, and you can format table like this. and check what you got. Nice. You can see that volatility volatility render option CSV added a property tree depth. So this property is only interesting when you are using a PS3 plugin. So if you want to avoid this property, you can do it quite easily. Let's edit here another pipe and do something like this: select object property, all properties, and now exclude property and copy the tree depth like this. Let's run it, and you can see that the property tree depth is gone, and you have here only the command line output. Can you spot something interesting here? This is not interesting, not services, nothing here. But what you can see here are previously spotted suspicious process 2852 SVC host, the 32-bit SVC host. It's running from directory of downloads, in user downloads. So SVC host running from downloads is 100% suspicious. So this is the main point of interest for us now. If we want to spot, for example, the main module path of the process, you can also use another plugin which is called DLL list. You can see DLL list here. So if you want to use if you want to see the main module path or module path, you can use this plugin. You will basically see all loaded DLL of the specified process. Or sorry, we can see that there are plenty because we haven't specified the bit of process ID of the process we are interested in. So if I remember, it was bit 2852. Yes, it was the bit 2852. And what you can see here, basically you can see only 64-bit DLLs and our main module of the process. You can again see the full system path of the main module, downloads directory, very suspicious for SVC host. But this, what you can see, is basically bug in volatility 3 because it's not able to properly print all or properly parse all loaded DLL in sysvov 64 in VOV 64 processes. Basically, if the process is a 32-bit application running on 64-bit operation system, you will get wrong result from DLL list plugin. So what you can do if you want to see all real loaded DLLs, or also from the path VOV 64 for 32-bit processes running on 64-bit operation system. There is one way how you can do it. You can use another plugin which is very useful, and basically it's called Wetinfo. Basically, this is the virtual address descriptor info, and this plugin is able to print you all memory ranges what your specified process is using. If the memory range is specified for some file, for example for the DLL, it will print you also the DLL name, so we can filter all DLLs in our specified process ID. So basically we can replace the DLL list plugin. So let's copy it, and you can basically only replace the plugin DLL list with Wetinfo. And if you want something different, because you can see if you do it here, what you get here, you basically, the lines are quite large for our screen, So what you can do here, you can basically change the last pipe, the format table, and you can basically do Out-GridView, and you will get something like table. Check it out. And this table is very powerful because basically you can filter properties, sort it, and do whatever you want, hide some columns or whatever you want. So basically, for example, if you want to only filter the DLLs which are used in our specified process svc host exe, the bit 2852, you can do it like this: add file contains .dll, and that's all. Nice. What you can see here, all DLLs which are used in our specified process svc host exe, the 32-bit one. You can see basically that before you were only able to see these modules, but these were hidden. Nice. All DLLs from our suspicious process. If you want to also, for example, hide some column, you can do it, right click, select columns, and for example, file output, hide it. Okay. Nice. You can change it, change the order of the columns and other stuffs. Very useful, the Out-GridView option. We can close it. We will be using the Vatinfo later. So now if we have our suspicious process 2852, let's use another useful plugin and check if we can spot another interesting things, for example, artifacts related to this suspicious process. For example, we can use a plugin which is called handles. This plugin is able, it's somewhere here, it's able to print all opened handles of this of specified process. So for example, if you again replace the plugin and do this, you will see all handles in a grid view. And again, really nice feature of this grid view is that you can filter and sort. So if you are, for example, not interested in some events and mutexes, semaphore and other handles, you can only, for example, filter like type of handle and containing file. If you are also interested in, for example, type of key, like register key, so just add key and you have it here. Sort it and you can see file handles and register key handles. Can you spot something interesting here? Here it is. User default software Loki. Loki is one. I'm 100% sure that Loki register key is not one of the default. So Loki may be something related to Loki ransomware. We will see it later, but it's something you can note. Now we will be using another very useful plugin, and it's called NetScan. You can see it here, the NetScan. And again, we can use our already prepared output formatting in PowerShell and replace only the netstat, but you have to delete the pit option because netstat has no option of pit, and do something like this. Oh, what you can see, what it was unable to read request page. Memdumppath versus netstat convert from, maybe something goes wrong. We can try it like that. And maybe you can see that there is some bug in netstat. Yep, page error. Okay, so there is some bug in netstat, but it's not important for us. We will do other stuffs with different plugins. If you want to try, for example, volatility 2, if it will be more successful, you can do it quite easily. You can, for example, switch to volatility 2 and run the volatility 2 like this, PowerShell, and clear window, vol.py, but it's Python 2, so let's specify Python 2 and print info. What you can see here, we have to specify the profile in volatility 2. I will try to use the profile Windows 7 Service Pack. Windows 7 Service Pack 1, 64-bit. Let's try it. Clear this window and specify the file and the profile. EQ this one, and the file, the path to our memory dump is here, dumped, properties, security, and here. Copy it, jump back to PowerShell where we are running volatility 2. Specify the path to memory dump. Profile is already specified, and if you want to see network information, just use a NetScan plugin. And let's check if volatility 2 will be more successful than volatility 3. Yep, no bug here. And that's basically confirm what I already said to you, that volatility 2 is in some kind of task still more reliable. So can we spot here something interesting? No, there is not our suspicious process ID 2852. You can see it here. Maybe it could be this one, which is already closed, but we cannot get the information from it. Okay, so you can close it, and let's come back to volatility 3. Now we will be doing the threat hunting, because we are quite sure that process ID 2852 is the suspicious one. We can use, for example, YARA rules, and we can use the YARA rule we already created. So let's check the plugins for it, and we will be using the plugin virtual address descriptor scan, VAD-YARA scan. Yes, this plugin we will be using. So let's copy this plugin. We don't need this anymore. Not, and only this. And let's check the help for this plugin. What are the options here? We can specify the bit, and we can specify the YARA file, YARA compile file. So we will be doing the specifying the YARA file. So path to YARA file, and we can use our previously created YARA file containing our suspicious string, and we can use it on all ranges of memory ranges of all processes, if we can see some matched results. It will take some time, but you can see it here that first bit which matched is bit 900, which is quite strange because this was not our suspicious process ID. Maybe it's the running. Yep, you can see here that 2852 process ID matched. So this is probably the creator of the randomly looking DNS names. But what is the process ID 900? We can check it. We can check it in one quite a nice way. Let's print command line and check the process ID 900. You can see 900 is SVC host running from system32, nothing suspicious, and it's related to network services. So it's false positive. Basically, this is holding all network related stuffs to our operation system is able to communicate to network. So it's absolutely obvious that this process will hold the DNS artifacts too. But the most interesting is that the creator one is 2852, basically our suspicious process. Okay, so now we can use another YARA rule, and we will be using YARA rule file, which I already prepared here. And as I already mentioned, you can download the YARA rules here. Here are the links, and if you download, for example, YARA rules from GitHub repository, you can see they are grouped in some folders. And if you want to use, for example, only malware, you can see that there are plenty of YARA rules. So if you want to merge it, just use my PowerShell script YARA rule merger. So if you want to use only, for example, malware rules, just go to YARA rules, download the YARA rules, you will get something like this, and just copy the malware. Copy them. You don't need the operation blockbuster. It's not related to our case. And just run PowerShell and use the YARA rule merger. So you can do it like this. YARA rule merger, and give me folder with all YARA rules to merge. So basically give the folder path of malware, properties, security, and here is the path. Copy it and put it to here. Okay, enter, and you will see quite a all YARA rules were merged. You can see it here, merged YAR. I already prepared malware merged YARA rule, so you can delete them. So this rule is the merged malware rules from GitHub repository. So we can use it in bad YARA scan plugin like this, malware merged YAR. Let's run it and check if we matched some suspicious or interesting process ID with suspicious there will be some false positives, so we can stop it, and maybe we can specify only the process ID. I want to print it quite fast, so we can do it like this, process ID and 2852. Run it and check if something can match in our suspicious process ID. And you can see Loki ransomware. So we can be quite sure that this process is Loki ransomware related. Okay, it's still running, but what we can do next is basically we can dump this main module which is related to Loki ransomware from memory space of this process ID. So let's stop it, and you can do it with plugin which we already covered here, and it's called virtual address descriptor info, VadInfo. You can see it somewhere here. I already use it, Wetinfo, and you can see here Out-GridView. Okay, and if you want to dump, for example, only the SVC host here, because this is the main module which is related to Loki ransomware sample. So if you want to dump it, you have to specify the star address which is 400,000. Okay, because as you can see, what are the options for the Wetinfo? Help. And you can see that you can specify process ID. You can specify dump option to dump the memory range, some specified memory range, and you can specify the address. Process virtual memory address to include. All other addresses ranges are excluded. This must be a base address. So as we already saw, you can do it like this. Wetinfo pit delete the rendering option. Windows info, process ID specified, address will be OX400,000 and dump. If you want to specify the output directory, you can do it here with O option, and let's put it to .dump. Okay, and let's dump it. And that's all. If you check it in dump, you can see here is the dump memory range, which contains from the process SVC host, the one suspicious one related to Loki ransomware. And you can see if you want to, for example, view it as portable executable, because if you check it, it has the MZ header, DOS header, P header, and other stuffs. So if you want to check it in some portable executable viewer, for example, pbur, bin, and you can do it like this, pbur. But what you can see here, that there are no import address table. You can see it here, and that's because this this memory range is still virtually mapped. So if you want to unmap this memory to repair the imports and section sizes and other stuff from virtual address to raw, you can use one very useful tool, as I already mentioned, made by Hashrez8. So you can do it like this. P unmapper, what is the help? You can see input file name, okay, slash in, and dump, and what are here is the dump. Specify the base was 400,000. You can see it in the file name also. And what is the next option here is output file name. So again, here, dumped, and unmapped SVC host bin. And there is another option also, the mode, but you can see that the default mode is unmapped from virtual to raw. So basically this is what we need. This tool is also able to map from raw to virtual and realign, but we want to use the unmapping option, so that's nice. Click OK and saved output. Okay, we don't specify it to out.exe. Okay, where it is. It was saved for probably here. Yeah, I don't know why, but we can basically rename it. Rename and unmapped svc host exe.bin. Yes, and copy it, to dumped. And if you check it in PEBur, you can see that it's already unmapped. It's in a raw original format, and if you check imports, they are already reconstructed. The sample is already repaired, and it's ready for another initial malware analysis and reverse engineering. If you want to do these steps in one step using only volatility, you can do it quite easily. You can do it with a plugin which is called PS List. We already use this plugin. You can see it here. And if you try to use it like this, you can check the options here, and you can see that you can specify the pit and dump extract listed processes. Okay, so we can specify the pit 2852, our suspicious one, and dump. And we can also specify the output directory .dump a. Okay, and that's all using volatility free. You can check that we again dumped it here, but this was performed with a PS List plugin, which is also able to automatically repair and unmap this module from virtual address to raw and automatically repair import address table and other stuffs. So if you want to check it again, so we can rename it SVC host dumped with volatility. Check it in PEBur, and you can see that it's already repaired. If you check imports, already repaired. So this sample is again ready for initial malware analysis and reverse engineering. And if you want to do it in other way, now it's time for another tool to shine. Basically, you will use a tool called PE3, and these are extensions for PE3. Basically, this PE3 is the default one tool for portable executable viewing. PE3 carve is able to carve out portable executables from binary blob of data. This is the extension for YARA, and this is extension for working with minidump. It is able to carve out the modules from minidump. And this is basically our extension for volatility free. We will be using this one and just specify the memdumppath. Let's okay. And what you get now, it's very nice overview of a process list where you can specify what process and what module you want to dump and repair. Let's check it. You can see the output of process list. You can see nice overview here, and let's find here is our interesting suspicious process. You can download all the modules, but you can only we are only interested in the main module SVC host. You can download one module with this option, but we want only the SVC host. Let's dump it and check it. Nice portable executable viewer, absolutely phenomenal. Image anti-headers, optional header, and other stuffs. You can also see, for example, section header. You can see sections, and all sections have some hashes here, and entropy and other stuffs. Very nice too. But what is important here, if you check the anti-header, if you check the anti-headers and import descriptor, you can see here that the imports are already rebuilt with this nice PE3 tool. Very nice, simple and fast. So let's dump it, and you can specify if you want to rebuild the import address table or rebuild from existing, but we saw that the import address table is absolutely correct. It was already repaired nicely, so we want to only keep existing. This should be okay. and save it to file. Dump it and specify the output directory dumped, and let's rename it pe3 dump svc host.bin. Save it, close it, check it. If you check it in PEBR, you will also see that all imports are already repaired, and again this sample is ready for initial malware analysis and reverse engineering. So basically I show you 3 different methods how you can dump modules from process memory space from memory dump using volatility, using volatility and dumping memory range, and using PER mapper, the tool made by Hashreset, and by using tool called PE3 with plugin for volatility free. And basically these 3 are basically SVC host, probably the Loki ransomware, which are already ready for initial malware analysis and reverse engineering. And this initial analysis and reverse engineering will be covered in part 2. So stay tuned, and that's all. I think that I covered all what I wanted, so stay tuned for the part 2, where I will be continuing with reverse engineering and initial malware analysis of some of this already repaired sample. So see you on the part 2.